Hello everyone. Today in this video we will do one problem which is related to construction of the cam profile for a radial cam. Generally in the cams unit we will get a combination of radial cam with a knife edge follower or radial cam with a roller follower problems only. So now we will do the first combination, that is radial cam with a knife edge follower problem. Now before starting the problem we need to remember two things. First of all, to draw the cam profile diagram, we need to draw the displacement diagram. Displacement diagram is the basic diagram, reference diagram to start the cam profile diagram. And one more thing is, in construction procedure of the cam profile diagram, we need to imagine cam is in the rest position and follower is allowed to rotate in the opposite direction of the cam rotation. So we need to remember these some basic guidelines before starting the cam profile diagram. Now this is our question. This is our problem. We will see the data which is given in the question now. Here a cam is to give the following motion to a knife edge follower. So it is a combination of radial cam with a knife edge follower. So whenever you get the combination of radial cam with a knife edge follower in the cam profile diagram, you will get two terms. First term is base circle and second term is cam profile, which you will get with the help of the displacement diagram and base circle directly. Now here outstroke value is given as 60 degrees of the cam rotation. So outstroke is nothing but a theta naught value. Theta naught value is given as 60 degrees. And dwell for next 30 degrees of the cam rotation. Dwell period is nothing but a rest part of the cam rotation. So dwell is given as first dwell. D1 is given as 30 degrees. Next return stroke during the next 60 degrees of the cam rotation. So theta R is given as 60 degrees. And remaining part of the cam rotation is given as 210 degrees for the next dwell part. So D2 is given as 210 degrees. Next, the stroke of the follower is given as 40 mm. So stroke is nothing but maximum tool travel in the reciprocating motion of the follower. That value is given as 40 mm. So with these 5 data we can complete the displacement diagram. Next, and the minimum radius of the cam is given as 50 mm. Minimum radius of the cam is nothing but radius of the base circle only, which you will get in the cam profile diagram. Next, the follower is moving with the uniform velocity during both outstroke and the return stroke. So here we all know that types of the motions of the followers are 3 types. In that one, first one is uniform velocity, second one is simple harmonic motion, and third one is uniform acceleration and retardation. So here they have given follower is moving with the uniform velocity, which is the first type in the types of the motions of the followers. So according to this type of the motion of the follower, we need to construct the displacement diagram with this given data. Next, draw the cam profile diagram when here two problems are there, A bit and B bit. Here A bit is axis of the follower is passing through the axis of the camshaft. That is nothing but for follower separate axis will be there. For camshaft also separate axis will be there. So here in the first problem both axes are passing through the same single point. In the second problem, axis of the follower is offset by 20 mm from the axis of the camshaft. That is nothing but cam axis will be somewhere, follower axis will be somewhere with some offset distance, that is 20 mm. So in this problem you will get one extra circle, offset circle with this offset distance 20 mm. That is the difference between the first problem and second problem. In the first problem you will get two terms like base circle and cam profile. In the second problem you will get 3 terms like base circle, offset circle and cam profile diagram. Now we will see the procedures to draw the displacement diagram and cam profile diagram in the first problem and in the second problem. Now before drawing the diagrams, scale is compulsory. We should take some scale according to the given measurements in the question, according to the given data. So here we will consider the scale as 10 degrees is equal to 1 centimeter and 10 mm is equal to 1 centimeter. This is the scale which we will follow for the displacement diagram and cam profile diagram in the first problem and cam profile diagram in the second problem. Now coming to the displacement diagram. Here first project the x-axis. For the x-axis just draw one horizontal line which is nothing but a x-axis base axis for the displacement diagram, and extend one vertical line which is exactly in the perpendicular direction to the x-axis, that represents the ordinate. Now here, and that represents x-axis represents the cam rotation and y-axis represents the displacement. Now according to the given data, we know theta naught value and d1 value, theta r value and d2 value. So divide the x-axis, base axis according to the perfect measurements into 4 parts. Like theta naught is equal to 60 degrees. According to the scale, 60 degrees will become as 6 centimeters. So after that conversions, according to that perfect measurements only, divide the base axis, x-axis into 4 parts. Like theta naught outstroke is equal to 60 degrees, that is 6 centimeters. Next dwell part as 30 degrees, that is 3 centimeters. Next theta r return stroke as 60 degrees, that is 6 centimeters. And dwell part, d2 part, second dwell 2 part as 210 degrees. We cannot represent the 210 degrees exact value on the paper, so use this symbol, that is nothing but approximately this part is equal to 21 centimeters. So once again, draw one horizontal line. That horizontal line is nothing but a x-axis, base axis, which represents the complete 360 degrees of the cam rotation in the mechanism. Now divide that 360 degrees according to the measurements which are given in the question into 4 parts, like theta naught, d1, theta r and d2 according to the measurements. Now here remember one thing, we need to measure the perfect measurements for theta naught and theta r compulsory. Why? Because we will use these measurements in the construction procedure of the cam profile diagram. So we need to take care that we should take the perfect measurements for theta naught and theta r. There is no need of perfect measurements for the d1 and d2. Why? Because we will not use the measurements from the displacement diagram to draw the cam profile diagram. Once again, there should be perfect measurements for theta naught and theta r. Those measurements we will use in the cam profile diagram. There is no need of perfect measurements for the d1 and d2. Like this, you proceed this procedure for the x-axis, base axis. Now coming to the ordinate, according to the follower motion value which is given in the question, that value is nothing but 4 centimeters, 40 mm. So with that exact measurement, you project one vertical axis, that is nothing but displacement value, stroke value. Now complete the rectangle by using this x-axis and y-axis. Now you will get a rectangle in this way. Now divide the rectangle into 4 parts. Like here, drawing one vertical line here and one more vertical line here and one more vertical line here. Now you are getting the 4 parts in the rectangle. Now divide theta naught value and theta r value into 6 equal parts. Like here 6 centimeters is there for outstroke and 6 centimeters is there for return stroke. 6 centimeters into 6 equal parts is nothing but 1 centimeter. So by measurement of 1 centimeter, divide this outstroke value and return stroke value into 6 equal parts. Now from the 6 equal parts in the outstroke and in the return stroke, project the vertical lines from the 6 equal parts. From each and every equal part in the outstroke and in the return stroke, project the vertical lines. Next, according to the default displacement diagram, for the first motion of the follower, when follower is moving with the uniform velocity, in the outstroke and in the return stroke, you will get the straight lines in the increasing order and in the decreasing order. So according to the default diagram, extend one straight line in the increasing order from the first point to the last point in the outstroke, and again same procedure in the downward direction in the decreasing order from the first point to the last point in the return stroke. Like this you will get the straight lines according to the default displacement diagram in the first motion of the follower. Next, mark the 6 equal parts in the outstroke and return stroke as 0 to 6 and 0 dash to 6 dash. Next, you are getting the intersection points for the vertical lines and here inclined straight lines. So mark that intersection points as A to G in the outstroke and H to N in the return stroke. In this way you will get 0 to 6, 0 dash to 6 dash, and A to G and H to N for the outstroke and the return stroke in the displacement diagram. Now with these representations we will draw the cam profile diagram. These representations are very useful to draw the cam profile diagram. Now here complete displacement diagram is shown by A to G, G to H, H to N, N to X. That is nothing but A, G, H, N, X is nothing but our displacement diagram for this problem. This is the displacement diagram. Now based on this displacement diagram and measurements from the theta outstroke and return stroke from this 1 to B, 2 to C, 3 to D, 4 to E, 5 to F, same in the same procedure up to 5 dash to M. From these measurements from the outstroke and the return stroke, you will draw the cam profile diagram. Now according to the first problem, cam axis and the follower axis is passing through the same point, single point. So that point we will consider as the origin point, O point. So here draw one small x axis and y axis, which is nothing but a axis of the camshaft. Next draw one vertical line which is nothing but a axis of the follower, which is exactly passing through the camshaft axis. So here follower axis and cam axis both are passing through the single point, same point, O point. Now we will get the first term in the cam profile diagram as base circle, and base circle radius value is given in the question. That value is given as 50 mm. So after the conversion you will get it as a 5 centimeters. So from the center point O point with the radius value 5 centimeters, draw one circle. That circle is nothing but a base circle. Now take the protractor, and by using the protractor and taking the base as the OA, divide the base circle into 4 parts like outstroke, dwell, return stroke, dwell, according to the perfect measurements which are given in the question. Like by using the protractor and by taking the base as OA for the first part like 60 degrees for the outward stroke. Next dwell part, D1 part as the 30 degrees. Next return part as the 60 degrees, and the remaining will be 210 degrees. So divide the base circle into 4 parts by using the protractor and by taking the base as OA. Here A is nothing but an intersection point of the follower axis and a base circle. That is the first point you will get for the cam profile diagram. Now do the same procedure which we have done in the displacement diagram in the cam profile diagram. Like we have divided the theta naught value and theta r value into 6 equal parts. Same procedure we will do in the cam profile diagram also, but difference is here we have done the procedure in the linear motion. Here we are doing the same procedure in the angular motion. Here you are getting in terms of the centimeters, like here 60 degrees like 6 centimeters, and with 1 centimeter we have divided the 6 centimeters in the outstroke and the return stroke into 6 equal parts. Here do the same procedure in angular displacement quantities, like here 60 degrees is there, here also 60 degrees is there. So divide theta naught value and theta r value like 60 degrees and 60 degrees into 6 equal parts in outstroke and the return stroke. So 60 degrees by 6 parts is nothing but 10 degrees. So with the 10 degrees, divide theta naught value and theta r value into 6 equal parts and mark them as 0 to 6 in the outstroke part and 0 dash to 6 dash in the return stroke part. Next, join from all that 6 equal parts to the center point in the outstroke and in the return stroke. Then extend that 6 equal parts in this manner. Extend that 6 equal parts in this manner in the outstroke and the return stroke. Next, from the displacement diagram, measure from 1 to B, and here from 1 to on the extension line which is coming from the first part, cut one arc. Next, again take the measurement from 2 to C in the cam profile diagram from 2 to cut one arc on the extension line which is coming from the second number. Next, take the measurement from 3 to D. Again do the same procedure. Cut one arc from 3 number on the extension line which is coming from the 3 number. Do the same procedure from 4 to E, 5 to F, 6 to G. Same procedure in the outstroke also. So you will get the arcs in the increasing order in the outstroke and decreasing order in the return stroke. Now mark them as A to G in the outward stroke and H to N in the return stroke, and join all those arcs, all those points. Now you will get a curve like this which is in a red color. That red color curve is nothing but our cam profile diagram. Cam profile. This is the first problem. Now we can say that the curve AG, N and again A is nothing but our cam profile diagram. Now we will see the second problem. Second problem is nothing but only some differences will be there between the first problem and the second problem. Here you will get a offset circle. Offset circle is nothing but here axis of the camshaft is somewhere and axis of the follower is somewhere with a offset distance of 20 mm. So draw the axis for the camshaft, that is nothing but O, origin point. Next, with the 20 mm 2 centimeters distance, project one vertical line, that is nothing but a axis of a follower. Next, with this measurement only, with the radius value as 2 centimeters, again from the O point draw one circle. That circle is called a offset circle. Next, again we all know that radius of the base circle is given as 5 centimeters 50 mm. So with that radius value, again from the O point draw one circle. That circle is called base circle. So with 2 centimeters from the O point you will get offset circle. With 5 centimeters again from the O point you will get the base circle. Now you will find one intersection point of the follower axis and base circle. That is the first point in the cam profile diagram. That point is nothing but a point. Now join O to A. This is the first line, base line, to divide the base circle into 4 parts like outstroke, dwell, return stroke and dwell. Now with the protractor and by taking the base axis as OA for the protractor, divide this base circle into 4 parts, like first part as outstroke 60 degrees, next dwell part 30 degrees, next return part 60 degrees and remaining part as 210 degrees. This is the same procedure we have followed in the first problem as well as the second problem. Here A is the intersection point of base circle and follower axis. Here also A is the intersection point of base circle and follower axis. We will take the baseline for the protractor for the first part as OA only. Here also we will take the baseline as OA only. Difference is here you are getting exactly OA on the y-axis. Here you are getting with some inclination. That is the difference, but remaining procedure is same only. Now divide theta naught and theta r into 6 equal parts. Here theta naught into 6 equal parts and theta r also into 6 equal parts, and name them as 0 to 6 and 0 dash to 6 dash. But don't join that 6 equal parts to the origin point. That is the difference. Here we will join all the 6 points, 6 equal parts in the outstroke and return stroke to the O point. But here we will not join them to the origin point. That is the difference. Next, draw the tangents from these equal parts to the offset circle. Draw the tangent line from the first part to the offset circle, from the second part to the offset circle, third part to the offset circle. In the same way from 0 to 6 and 0 dash to 6 dash. Once again, draw the tangents from these equal parts in the outstroke and in the return stroke to the offset circle. Next, extend that tangents. Now Do the same procedure which we have done in the first problem by taking the measurements from the displacement diagram to get the alphabetical letters from A to N. Now measure from 1 to B, and here from 1 to on the extension line which is coming from the one, you cut one arc, that is nothing but a B point. Next from 2 to C, here also cut one arc from 2 on the extension line which is coming from the 2, you will get a C point. Do the same procedure by taking all these measurements from the outstroke and the return stroke, and you will get the arcs in the increasing order in the outstroke and in the decreasing order in the return stroke, and join that arcs intersection points as A to G and H to N in the outstroke and in the return stroke. Now join all that intersection points. Now you will get a curve in this way which is in the red color. So from A to G, H to, sorry, here one more letter is there, here I to N, and again N to A. This complete curve is nothing but our cam profile diagram. So once again we will see the differences for the first problem and second problem. Here in this problem, cam axis and a follower axis is passing through the single point. Here cam axis and a follower axis is having some distance apart with a distance of offset distance 2 centimeters. Next here you will get only two terms, base circle and directly cam profile. Here you will get base circle, offset circle and cam profile diagram by using offset circle and base circle. Next, here join all the 6 equal parts to the origin point. Here don't join all the 6 equal parts to the origin point. Next here, extensions you will get from the joining lines up to the origin point. Here draw the tangents from the 6 equal parts to the offset circle. Then procedure will be same for the first problem and second problem by using the displacement diagram. Then you will get the intersection points of the arcs and the extension lines. From this you will get the cam profile diagrams in the first problem and in the second problem. Once again see the diagrams. This is the displacement diagram according to the first type of the motion of the follower. Next, this is the cam profile diagram for the first problem, and this is the cam profile diagram for the second